You've probably heard the term slope thrown around in math class, right? Well, what if I told you it's way more than just some formula you have to memorize? At its heart, slope is actually a way to tell the story of change that's happening all around us. We're talking everything from how steep a mountain is to how fast your savings are growing. So today, let's uncover that story together.
Okay, let's just jump right in with a super simple visual. We've got two roads here, Road A and Road B. You don't need to be a math whiz to have a gut feeling about these two.
I'm willing to bet you immediately pointed to Road A. And you know what? Your intuition is totally spot on. It just looks like a tougher climb. But the real question is, how do we turn that feeling, that intuition, into an actual number?
And that's it. That's all slope is, really. It's just the official mathematical word we use to measure that exact idea of steepness that you just recognized in a split second. So now that we know what we're talking about, let's build on that gut feeling and actually learn the language of steepness.
The whole secret, the core idea, comes down to two little words: rise and run. Just think about it this way. For every step you take forward, that's the run. How much do you go up? That's the rise. The relationship between those two, rise divided by run, that's what gives us the slope.
Let's apply this to our roads from before. For the exact same 50-foot run, Road A goes up 30 feet. That gives it a slope of 0.6. But Road B, it only rises 10 feet over that same distance, giving it a slope of just 0.2. See? The bigger number, 0.6, proves what we already knew in our gut. Road A is steeper. Our intuition now has cold, hard numbers to back it up.
Okay, so we've got the concept down pat. Now, let's get into the nitty-gritty. How do we calculate this for any 2 points in a line without having to draw it out every time? Well, that's where the famous formula comes in.
And here it is. Now, don't let all the letters and numbers intimidate you. M is just the symbol we use for slope. No big deal. And if you look really close, you'll see it's just a slightly fancier way of saying rise over run. The change in the y-coordinates is our vertical change, our rise. And the change in the x-coordinates, that's our horizontal change, our run. It's the same idea, just dressed up for a formula. Let's put this formula to the test with a line on a graph. So here we have 2 points. We're starting at 2, 8, and we're ending up at 8, 32. Let's figure out the slope between them.
All right, let's break this down. First things first, we label our points. Then, we just pop those values right into the formula. On top, we get 32 minus 8, and on the bottom, 8 minus 2. That gives us 24 divided by 6, which simplifies down to a nice, clean slope of 4. Simple as that. Now, I know what you might be thinking. What happens when negative numbers get involved? Things can get a little tricky, right? Well, the good news is the process is exactly the same. You just have to be a little extra careful with your signs. Let's walk through one together. So we plug in our values. On top, we have 2 minus -4. And remember, subtracting a negative is really the same as adding, so that becomes 6. On the bottom, -5 minus 3 gives us -8. So our final slope is -3/4. And what does that little negative sign tell us? It just means the line is going downhill as you look at it from left to right. That's all.
Okay, let's talk about a couple of weird ones, the special cases. What if a line is perfectly flat, totally horizontal? Well, it has a rise of 0, right? So its slope is 0. That makes perfect sense. But what about a line that's perfectly vertical, like a wall? In that case, the run is 0. And since dividing by 0 is the one big no-no in math, we say its slope is undefined. You can just think of it as an infinitely steep line.
All right, now for the really cool part. Let's see how slope fits into one of the most famous equations in all of algebra, and how that little equation can actually tell the whole story.
I'm sure you've seen this one before. Y equals mx plus b. This is called the slope-intercept form. And look who's right there in the middle, our old friend m, the slope. The b is just what we call the y-intercept, which is a fancy way of saying your starting point on the graph.
This is where it all clicks together and starts to make sense in the real world. Think of x as your input, like the hours you work. M, our slope, is the rate of change. That's your hourly wage. B is your starting value. Maybe you got a small bonus for starting the job. And Y, that's your output, what you end up with, your total paycheck. All of a sudden, this isn't just a random equation. It's the story of how you get paid.
So what happens when an equation is a bit of a mess and doesn't look like our nice, neat y equals mx plus b format? No problem at all. We just have to do a little rearranging. Our only goal is to get y all by itself on one side. So here, we just move things around a bit. And once we isolate y, we can see it plain as day. The number right next to x is our slope. In this case, it's 3/4.
So let's bring this all home and see how this one single number, the slope, tells a powerful story in situations you probably deal with every single day.
If you take away one thing from all this, let it be this right here. Slope is not just about steepness on a graph. It is the rate of change. It tells you exactly how much one thing changes when another thing changes.
Take a look at this phone plan, for example. The graph is a perfect straight line. What does that tell us? It tells us the cost goes up at a steady, predictable rate the more data you use. And that rate of change, you guessed it, that's the slope.
And if we look at the actual data, we can see that for every single gigabyte you go over your limit, the cost jumps up by exactly $15. So the slope of that line is 15. It represents the rate of change, $15 per gigabyte.
Here's another one, a cab fare. There's a starting cost, a flat fee, just to get in. And then, after that, the cost goes up for every mile you travel. That price per mile, that's the slope. It's the constant rate of change for your ride.
So, as you can see, slope is literally everywhere. It's not just some abstract math idea. It's the story of how much you earn per hour. It's the cost of a gallon of gas. It's how much your salary goes up each year. Anytime something changes at a constant rate, you are dealing with slope.
So I'll leave you with this question. What in your life changes at a constant rate? A subscription service? Your commute time? Now that you understand the story of slope, you have a brand new tool to see and describe the world around you. So what stories are you going to uncover?